How's it going, AS Math? It's Mr. Knight. We are going to actually kind of switch gears just a little bit. I know we were just learning sectors a little bit ago, and now you're like, why is there a graph in front of my face now? We're going to go back. We're going to look at our trig graphs, specifically sine and cosine, and we're actually going to learn some useful transformations that aren't just useful for trigonometry. They can actually be useful for a lot of different even of your like algebraic functions that we're used to, like the quadratics and the linears and things like that too. Of course, they just have a preference towards sine and cosine. So yeah, let's see what we can do about that, and let's see if there's some rules we can generate from this. So I'm giving you the graph f of x equals sine x, and we've seen this guy before, right? But what about something like this now, right? Now there's a lot more going on. Okay, we have 4 new parameters. We're going to define a parameter as any characteristic that can help in defining or classifying a particular system. So these 4 things, if you will, we're going to refer to as parameters. And each of these parameters does something different, it turns out. And it looks like it'll be a lot, but it's really not. We're going to break it down a little bit, okay? This is how those parameters look and compare in general. We can actually assign some variables to them, some constants, and that is A, B, T, and S, and we're going to see what each of those parameters are actually doing. We're going to take a trip to Desmos and see what's going on. All right, here we go. We have this graph right here. This is y equals sine of x right here. And what we're going to first do is we're going to see what the plus s does for one of our parameters. Okay, so I would refer to the in general part for right now and look at that equation. And I'm just going to play this, and we're going to just see what happens. Whoa. Okay, so you could see what's going on. This sine graph is just vertically translating up and down. That's all it's doing. In fact, this is all that the s parameter does, is it just changes your location in your y value. So if you had 0, 0 before, and I make this plus 1 now I'm at 0, 1, right? So it's really only changing the y values. My x values are not changing at all. So let's go ahead, let's actually write that down. We're going to get a little chart going of each of these parameters. And here's our first parameter right here. We're going to call these the stab transformations because we're using S, T, A, and B. And I mean, I could make bats out of it, but stab is just like, ugh, like it just sticks out more rather than just saying bats. You know what I mean? I don't know. So stab transformation starting with the S. Yeah, it's just shifting it up and down. So if you see something that's a plus S, it's going up. If it's a minus S, it's going down. And the book continues to use kind of this weird notation right here. If you could just say that this was like an x comma y point, it's just saying that our y value is being changed by plus or minus s. And so that's all the s parameter is really doing. So if you look at this notation over here now, instead of x comma y, we're generally dealing with theta. Sometimes we do x, but sometimes we do theta. So theta comma y, and then I'm just in purple, I'm telling you, hey, it's just your y value that's changing, okay? Let's go ahead, let's look at the t now. Let's see what the t's doing. All right, thank you. First sine, second sine. How's it going, dude? I'm going to play this, see what goes on, and there it goes. It's going left and right, so it's a horizontal translation, it turns out. Now, the general form of this guy is sine of x minus t. So for example, if I have t equals negative 1, it's going to show up as x plus 1. X plus 1. But as you can see, if I'm negative, I'm actually going to the left, right? If my t value is negative. So in the actual function itself, if this sign turns positive, that lets you know your t value is negative and you're actually going to the left. Whereas if your sign stays negative, well, then your t value is positive. You've been shifting to the right. Okay, let's write that down. Let's formalize that a little bit. The t is our horizontal translation. And ignore the fact that I'm using plus s and minus s like a dingus, okay? This is supposed to be t and t. But a plus t is going to be a shift to the right. A minus t is going to be a shift to the left, okay? It is always of this form, okay? So just be mindful of your signs, okay? Because this is probably the biggest part that could get confusing. It's kind of the opposite of what you think it's going to be, all right? I'm specifically talking about the t, not just this sign right here, okay? It's just a horizontal translation, so our angles get affected, but not our y values, not at all, okay? All right, next one. Let's look at the a. Hey, how's it going, man? Do that? Whoa, okay. So, what is happening with this guy right here? Well, what's happening is our y values are actually, currently, they're going to stretch, and then they're going to compress. Okay, so when are they compressing? When are they stretching? They're stretching, so if we just have a equals 1, which is what it normally is, and I go higher, this thing just starts stretching out like a rubber band. Okay, so it's going up. But even if I go, this way, it's also stretching, but what happens when I go from negative to positive? Oh, it's like a reflection about my x-axis. It's kind of interesting. So it just changes my y values up. And another thing too is when it's compressing. So it looks like at 1 it's fine, and then as soon as it's less than 1, it starts compressing until it's flattened out at 0. Okay? Interesting. Let's formalize that too. All right? This stretch is parallel to the y-axis. You saw it kind of stretching and contorting in that way. If the absolute value of our a is greater than 1, so even if it's -2, this would still hold true. It's a stretch, and we saw that. Whereas it gets less than 1, it's a vertical compress. It gets flattened out. And then a reflection is when it's a negative. You saw that it reflects about the x-axis. Okay? And it's a stretch scale factor of a. So really all we're doing is we're taking our y values and we're just multiplying by the a value. Okay? And let's look at the last one. And you could probably guess what's going on. We went vertical, horizontal, vertical, kind of, with the y-axis. Wonder what this one's going to be. Let's see. So this one is actually multiplying our x value, our angle, what's in here. And if I do this one is probably the most jarring one. It's also the hardest one to see exactly what's going on. It looks the coolest, though, for sure. What is happening? It looks like a spring, right? Again, it's compressing, and then it's stretching, and then compressing. It's doing a lot. It's like a slinky, kind of. It's doing a lot of cool stuff. So, again, let's break this guy down and see exactly what's going on. When this guy is greater than 1, it looks like it's starting to compress. And then as it gets less than 1, now it's kind of stretching out. So it's kind of the opposite of the last one in a sense, right? This one is actually doing a little bit of opposite, but it's also in the x direction as well. Which is of note. This is really hard to see what the scale factor is, so I'm going to just honestly give it to you guys. Let's take a look at what's going on. So, again, I messed up, so bear with me. Okay. Remember, as we were just seeing, it was kind of opposite of what we were going on. As our b value gets greater, we're actually seeing a horizontal compress, and as it gets less than 1, we see kind of this horizontal stretch going on. What's going on is it's affecting the period of our graph. If you remember with sine and cosine, the period of our graph is 360 degrees or 2 pi radians, okay? So what this does is that it actually takes our y values and it multiplies, it takes our x values because it's in the horizontal direction. It takes our x values and it multiplies it by not just b, but 1 over b. And it gives us a brand new period. So it's 2 pi divided by b. Or you could even do it as 360 degrees divided by b, right? That means if b was 2, so if I had like, I don't know, y equals sine 2x, basically our period is now going to be, instead of 360 degrees, it's going to be 180 degrees. It'll cut it in half. It'll take only 180 degrees to complete a full cycle, which might be difficult to see right away. But let's go ahead. I'm just going to compare it to this graph right here. I'm going to make everything about the same except that. Yes, and now they look really waxed. So this is our base form right here, okay? And then this is when we multiply our x values by 2. It compresses it up a little bit, just like pushes it in. And I know it's hard to see, but it basically takes it and it makes it put in half. So a full cycle is from here to here. We've done a full cycle. For the blue one, a full cycle is only to here. And if you compare that to the other one's longer by about 2, times 2, okay? So we're going to get some examples and just kind of see what's going on with this. Let's do that, okay? All right, here's our first example. We have, starting with the curve y equals cosine x, I'm going to show how transformations can be used to sketch these curves. So first part is cosine 3x, and you can see the rest. I don't have to read them all off to you, but each one of them is dealing with a different parameter of stab. Okay, so the first one we're doing is actually our b in our stab. And here's some tips to help you out, okay? I would use an XY chart of sine or cosine with like the normal angles, so 90, 180, 270, 360. Easy angles we know the y values to. And then apply your stab. Apply your scale factor transformations first, so what you're multiplying, and then do your translations. It's kind of like order of operations. Multiply before you add, okay? So let's see this first one. Y equals cosine 3x. I'm going to take the base form of y equals cosine x, and I'm going to make an xy chart of that. So I got 0, 90, 180, 270, 360. And I know those y values because I have my cosine chart. Or I just know them. 1, 0, negative 1, 0, 1. Okay. Now this 3, again, this is our b. So it affects the x values by a factor of 1/3. Okay, it just affects the x values, and it's a scale factor, so that means it's kind of like dilations in geometry. You're going to take your x values, and you're just going to multiply them by 1/3. That's all you're going to do. We get our new x values right here. The y values, they don't change at all. And now this is our new graph right here. It looks pretty much the same. That's because it should. The only differences are, now our period, instead of going 0 to 360 degrees, we've cut it in thirds. So I've only gone 1/3 of the way from 0 to 360. So now 0 to 120. And I've completed one period in that time. And all I did was multiply my cosine x xy chart by my one scale factor in this problem. Okay? And I only had to deal with one parameter. Yes, we'll see later dealing with multiple. Okay? All right, that was part 1. Let's see the other ones, how this works. Okay? Part 2, we have 3 plus cosine x. This is our plus or minus s in stab. Okay? The 3 is affecting our vertical translation, and it's doing our y values if it's the vertical translation. So once again, our base cosine x table, and now this one has cosine x plus 3. And again, only the y values are getting affected. So I take my known ones, and I just add 3 to all of them. I get my new y values. And as a result, I get my new cosine graph. It looks kind of weird, I'm aware, but I kind of had to scrunch it up a little bit because now we're just going between 2 and 4, not negative 1 and 1 before. Okay? That's the only reason mine looks like that, but it's still kind of doing that sine, cosine-like pattern. Right? Let's look at part 3. Now we're dealing with the minus t. Now, because it's already as a minus whatever, our t is just 60. It's a positive 60 degrees. So it affects our horizontal translation, and because it's minus 60, it's going to be a shift to the right. So we end up with our x values that we know about, I end up just adding 60 degrees to each of those to just compensate for the shift. And so now I have my new x values, and there we go. And I just fill in my y values, and just like an xy chart. So it's not too bad. It's not too bad. And the last one, we'll go ahead and just finish her off. This is y equals 2 cosine x. 2 affects the y values by a factor of 2. It is our, with the stab, it's our a, okay? So it affects our y values, our vertical stretch and compressions. All I do is I take my y values and multiply them each by 2, and so it just changes our range up a little bit. I'm not going to graph it for the sake of time. I think you get the point now, okay? But let's look at example 2. This is another type of problem you might encounter on your homework. So we have, one second. What we have is this function g of x, and it equals a plus b sine of x. It's defined from 0 to 2 pi, or 0 to 360 degrees. Given that g of 0 equals 4 and g of pi over 6 equals 5, we need to find the values of a and b. Then we need to find the range of g, and then we need to actually sketch the graph. Okay? So let's find the values of a and b. Now, this information it gave us here, where we plug in like these angles and get out y values, is critical for this part. So I take my g of x equals a plus b sine of x. I write it like this because I'm not insane. And then I take g of 0 equals 4. So now that means I'm plugging in 4, or I'm plugging in 0 for x, and I'm getting out a 4. So my g of x is going to equal 4. And so 4 is going to be equal to a plus b sine of 0. I'm plugging in 0. Well, sine of 0 is just 0, so b's gone, so a equals 4. Now I know what a is. Plug that in. I now know that if I plug in pi over 6, I get a 5 for my y value. So 5 equals 4 plus b sine of pi over 6. Pi over 6 is also just 30 degrees, and sine of 30 degrees is 1/2. And so to find b, it's multiply both sides by 2, and you get b equals 2. And there we go. We found a and b. So now let's actually get the range of this. Now, if we're looking at the range of this, first of all, the range, once again, it's the y values. And we have 4 plus 2 sine of x. Both are actually affecting our y values. So I need to multiply by 2 first, and then add the 4, just like I showed you guys earlier with those tips. So I take my sine of x, and I write my x and y values that I know about. Then what I'm going to do is I'm going to keep the x values the same because they're not getting affected. And my y values, I multiply first, and then I'm going to add my 4, and I get my new range values. Now, I want the range. So what's my smallest and what's my largest? Well, my smallest value is 2, largest is 6, therefore my range is between 2 and 6, which is different when it was between -1 and 1. And so I can go ahead and graph this. We're just going to graph this guy. I'm going to make a radian graph. It's no different than a degree graph. I just wanted to make it because why not? We haven't seen it a whole lot. And so 90 degrees, 180, 270, 360. I have those known values, and then I just put in my y values and plot this like an XY chart. And bada bing, bada boom, I am done, son. Okay? So good luck on your homework. This is pretty much the main 2 type of problems that you'll encounter, and have a good day.